In this video, we are going to determine the number of solutions of a system of linear equations. What is a system of equations? It is a set of two or more equations with the same variables. Like these two equations, these are system of linear equations, where we have two equations with the same variables x and y. An ordered pair that is a solution of both equations is a solution of the system. A system of two linear equations can have either one solution or an infinite number of solutions or no solution. As shown here in the three graphs, we have one solution if we have a point of intersection, no solution if there are two parallel lines, and infinite number of solutions if we have the same line for both equations. The system of linear equations can be either inconsistent or consistent. Inconsistent means there is no solution, and consistent can be independent if we have one solution, or can be dependent if we have infinite number of solutions. Let's have an example. Use the graph to determine the number of solutions the system has. Then state whether the system of equations is consistent or inconsistent, and if it is independent or dependent. Here is the system of equations, and here is the graph. So, since the graphs of these two lines intersect at one point, then there is exactly one solution. And this solution means that the system is consistent and it is independent because we have only one solution. Here's another example. Again, use the graph to determine the number of solutions the system has. Here we have the two equations and the graph of the two lines. As you see here, since the graphs of these two lines are parallel, then there is no solution of the system, and this means that it is inconsistent. Now it's time to check your understanding. You can pause the video till you solve and then check your answer. And here are the answers. Another example. Determine the number of solutions the system has, then state whether the system of equations is consistent or inconsistent, and if it is dependent or independent. If you look at the two equations here, you will find that it is written in slope-intercept form, where the slope is 6 in both equations. So the slope are the same in both equations, and the y-intercepts are different. So this means that the two lines are parallel. This means that it is an inconsistent system of equations. Another example. Here we have a system of linear equations with two equations written in standard form. First, we are going to rewrite both equations in slope-intercept form to find the slope of both equations. Here are the steps to rewrite both equations in slope-intercept form. We isolate the y on the left-hand side and we move the x and all variables on the right-hand side for both equations. Now we have two equations in slope-intercept form. As we can see here, we have the slopes are the same and the y-intercepts are also the same. This means that both lines are the same line. So we have infinite number of solutions, and this means that it is consistent and dependent system of equations. For more practice exercises, you can click on the link in the description part of the video below. I hope this video was useful. If you like it, please press like, subscribe, and stay tuned for more videos. So, to the next video. Bye.